Everyone. I just wanted to take a few minutes here and go over a few things regarding the material in this chapter to make sure you understand the main difference between wind-caused waves and the tsunamis that we're looking at. Because if you've read through the chapter at this point, you can see that tsunamis have a somewhat different impact as far as they tend to be much more destructive. And the way that they form and move onto land is a little bit different than the way that wind-caused waves do. So I want to take a few minutes and kind of try and help you visualize, the differences between how those waves form and the way that they act. So I thought I'd put together this little lecture for you. So if you'll just kind of bear with me, I'm getting used to this new screenwriter that I have. So I want to try and do some couple illustrations and things here to try and help you visualize exactly how those waves form and the different ways that they move onto land. So let's get started here. First thing we're going to do is take a look at basic ocean floor. The further out you get, it's going to get deeper and deeper, and so we're going to call this out here our beach. Alright, so this is basically land. This is where you see waves break, and then we have water here. Okay, so the thing to keep in mind when you're looking at waves is basically a wave is actually more an energy disturbance moving through water as opposed to the water actually moving. So we're going to take a look at wind-caused waves first. So what happens basically? We get some wind. There's always wind at the ocean, and it's going to blow across the water. So you have wind blowing across this way, and what that does is it causes some sort of disturbance here. So when we have that disturbance, it's going to affect the way I think about it is a certain volume of water. So when we have this disturbance, let's just say this much water, just to help you visualize it. Now again, this isn't exactly what's happening, but just to help you visualize, just picture this block of water is what's going to be disturbed. Okay, so now that disturbance is going to continue to move in the direction towards the beach. So we have wind blowing this way, and that's going to cause this disturbance to move this way. So one thing that's important to understand is this water right here does not actually move. It's the disturbance that moves through the water. So as that disturbance moves closer and closer to the beach, we're going to have the same level of disturbance or the same volume of water being disturbed here. So you can see what happens as we get closer to the beach. That disturbance is getting closer to the ocean floor here. So essentially what's happening is this volume of water, these are the same, this one and this one, is being squeezed into a smaller and smaller spot. So that's going to cause that disturbance and the amount of water that it's disturbing to push upward. We're essentially squeezing it into a smaller container. The energy that's disturbing that water is squeezing that water into a smaller container. So that's going to continue to happen as we get closer and closer to the beach. That disturbance is disturbing the same amount of water, and that's going to cause the water to continue to build up on itself because it's essentially getting into a smaller and smaller container. You see these distances are getting smaller. So what happens then is the water down here, as it gets so close to the ocean floor that it starts to touch, sorry about that, the water down here slows down. And the water here is going to continue at that same speed, so it's going to want to keep going like this. And that's what causes the breaking of a wave. If you've ever been to the beach, I'm sure you've seen pictures. As a wave gets to the beach, it kind of takes on this typical wave shape and crashes down on the beach. So wind caused waves, and again, the main thing you want to focus on is that this is some sort of disturbance that is moving through the water. As it gets closer to the beach, it's going to build up to the point where it finally breaks. Right, so that's wind caused waves. Now, let's contrast that with our tsunami. So again, we're going to have an ocean floor here. It's deeper and deeper. Have some water up here. All right, and now down here, we want to look at our plates, our ocean plates. So where we see tsunamis typically is at some sort of, typically they're at convergent zones. So there's one plate on the left and another plate on the right. There's plate 1, and here's plate 2. Okay. So what happens then is we're still with a tsunami because it's a wave. It's just a disturbance of energy that is moving through this water. But what happens now, instead of the disturbance just coming across the surface here and disturbing some small amount of water up here, what we get is a plate shift. So this plate might shift upwards considerably. So the first thing you should notice is that because this disturbance is caused by a plate as opposed to wind, we're getting a much larger volume of water disturbance. So all this water is being shifted up. So if you think about the plate tectonics and things that you've learned at this point, you know that plates are hundreds of square miles, thousands of square miles big. So if you can picture, you know, this is a cross-section view, but this is a huge plate going this way, and then it extends in all directions. So we get this huge volume of water essentially getting pushed directly straight up. So all of this water is being disturbed. So the first thing to keep in mind with the tsunami is it's a much larger disturbance, so a much larger volume of water is being shifted up. Now, just like in wind-caused waves, that disturbance is going to continue to move its way towards the beach. Now, instead of with wind-caused waves, this mass of water essentially is going to build up and continue to push its way forward. We don't have, if you read in the chapter, we don't get that orbital motion that we get with wind-caused waves. Essentially, we just have this huge wall of water and this disturbance pushing it forward. So when a tsunami makes landfall, the leading edge actually looks a lot like this. And because all of this water is being disturbed, as opposed to getting caught up at the bottom like with wind-caused waves, this entire wall of water is what moves on to land. So that is why tsunamis tend to be much more destructive. They typically don't break the way that we see wind-caused waves do. This whole mass of water just pushes its way on to land. So that's basically it. Again, just to summarize, you know, the key point with understanding a wave is that it's just a disturbance of energy being transferred through the water. And then the two differences are going to be that wind-caused waves tend to disturb a smaller volume of water due to the fact that it's just wind blowing across the surface, whereas tsunamis are going to be this large mass of water that the energy is being displaced by a plate movement. So that's basically you know, the key points to understand in terms of the difference between wind-caused waves and tsunami waves. You know, please make sure you look through the chapter and the PowerPoints. There's some additional information regarding specific case studies of tsunamis and the type of damage that they cause. So again, as always, if you have any questions, post them on a discussion board, and I'll be sure to get back to you, or feel free to email me directly. Thank you.